Okay, you've probably all seen the trick that Gauss did. I haven't posted it up as a note, and yes, the answer is 5050. And my follow-up question was, can you draw a diagram to explain it? And the reason we're doing that is it gives us a quick way to actually sum up any arithmetic sequence. When we talk about arithmetic sequences, they are ones that go up in simple numeric steps. So we'll just take Gauss's one there. And what he started with is, pictorially, you start with your first block, which is 1, then the next one to it's 2, and then 3. And when you get to the end of the list, you've got block 100. And it's 100 high. And what the formula is actually saying is, I've got 100 numbers, but I can pair them off. I can split them into pairs where the first number and the last number pair off. So we stick the 1 on top, so we get a height of 101. And that's in pairs, so there's going to be only half as many pairs. And that's where the formula actually comes from, is that there's 50 times 101 is 5050 is the total. And that's effectively turning all of these separate blocks into blocks which are all the same height. So all these different blocks, by pairing them off, largest and smallest, they will always pair off to come out to be the same height. If we try another sequence of things like 7, 14, 21, 28. If I pair them off, the first and last are 35, middle two are 35. So what we've got is, we have 4 numbers that started with 7 and ended with 28, which gives me my 35. That's the total of the pairings. And we want half as many of them. So this will give me a way of calculating the sum and say that the sum of this is 70. If you add them up, we've got 21, 42, 70. And it works. It works quite nicely for this. The pattern of this pairing this way also works even if it's odd. So if I go one more high, what actually happens with it, so we're now going up to 35, is we get 2 pairings here, which make 42, and we make another pairing here that's 42. So that's 2 pairings. And the third one is already split in half to give us this 21. So this pattern even works even when it's odd, this dividing by 2. Because what we've got is we've got 5 numbers. 5 numbers gives me 2 pairs and 1 odd one in the middle that is half the size. So it's still working. So we'll try and turn this into a bit of algebra. Let's take those 5 numbers. I'm going to call the first number A. Don't know why they called, well, just because it's the first letter. So this number, A, and the last one is L. And we know that there are n numbers in the list. So the formula we're going to use, if we take the pattern we used above, we had the first plus the last. Multiplied by the number of items, and then divide by 2 for the pairing. And that will tell me the sum. So if you all remember, can you click your microphone if you're happy? If you've got a problem, remember you can do raise your hand. I forgot to mention that to previous classes. You're all happy with that as it is? Yeah? Okay. That's where that formula comes from. It works. And it works because if you were to think of them as being columns, each column is going up by the same difference. And that's the next step we need to look at, is we need to know how to form the difference. Now the difference is just the gap between these two numbers. How many lots of the difference do I need to get from the first to the last number? So is there anyone able to think, how can I calculate what the last number is if I know how many numbers? So I want to do the sum of, where is it? They're getting a bit big. We'll stick with this example. What's the sum of the first 8 numbers going to be? So I know it goes up in sevens. I know there's going to be 8 of them. A, I know, is 7, and my difference is also 7. Anyone know how to calculate that last number? The reason I'm doing it, it's a little bit of a query. That's it, Andre, you got the right one. It's the first number plus. Can you explain why I've got to do n minus 1 in it, Andre? So the last number is the first number.
You have like one less distance in the number of numbers that you have.
Yeah. So if you think about counting steps, the number of steps to go from the first to the last is 1 less than the number of steps involved. If I've got 2 steps, there's only 1 step in between. If I've got 5 steps, I only have to do the jump between them 4 times. And it's the jump that's important for this one. Okay? So that's where that comes in, is we can create a sum using this number. So now I can create another version of this formula where we don't have an L at all. We can find out, knowing the first, the difference and how many terms, we can now calculate the sum. And we can do it by either calculating the last term and using this formula, or we can say the sum is equal to n over 2, a, plus our expression for L. So we've now got a plus n minus 1 times d. And this sum is n2. We have 2 a's plus dn minus 1, I think, is the order they do it. Doesn't matter if you get them the other way around. But that's where this formula comes from. And the reason you need to know about this formula is that's the one given in the exam. They will give it to you. So this version of the formula is given to you. This version of the formula is often quite handy to know. If you know certain things about the sequence and you know the first and last values, you then don't have to go away and find out how many terms were there or what the difference is all the time. It's actually able to calculate it directly. So I've given you 2 options there. But what you do need to remember is what Andre just said, that the number of steps now is not quite the same as when we've been doing sequences. This is series, and series is about adding things up. So we've got a series, which is a sum. And the sum is actually 7 plus 14 plus 21 plus. And they often say the sum of that series is Sn. And it's got a lowercase n. That's what Andre was showing with the A1. The first term is A number 1. They often actually, instead of saying L, any term can be given by An is equal to A1 plus n minus 1 times d. And that gives us any position we like. So if n is 1, we get 1 minus 1, this disappears, that's the first term. Okay, so that's just a little bit on notation. What we've seen before is sequences, and sequences are just a list of numbers. And what you might suddenly think, if you think about the sequences, is when we write this general formula, we normally talk about the 0th term. And this is what that 0th term is dealing with, is this minus 1d. We're going back one step to find out what would be in the position 0. And that's what normally is used in sequences. But with series, we want to include the first term, second term, third term. And that's why it needs that n minus 1 term in it, is because we're starting from the 1th term. The reason they use that 1 version there is this becomes a little messier when you change it to counting as if it was sequences. So I've given you the exercise in the book, page 153, I think it was. Let's just have a quick look at a couple of the questions, something similar to that. So if we have a look at something like question 1, I'll just give you a couple of quick questions of how you can solve this. It's not question 1 itself, I'm just going to do something very similar to it. What if I want to know the 6th term? Oh, that's doing another example. I'll do that one in a minute. So if I've just got some basic sequences, the first term is 10. The difference is going to be, I'll do 6. So I now know this goes up in 6s. So we're now doing, what's the sequence? 16 plus 22 plus 28 plus 34. So you can work those ones out in a moment, and we'll work out what the sum is. But we'll do it with this one for the series, n equals 5. Two ways of going about it. One is to use their formula. S of 5 is the 5th term times 2 lots of the start plus the difference times the number of jumps we had to make. So that's 5 minus 1, 4. And we have half the number of pairs. If you chuck that into your calculator, we should get a sum. Hopefully it works out right. 5 divided by 2. Multiply that by 20 plus 24. Which gives me a sum of 110. That's one method. I could work out the last term. The last term, which is going to be the first term plus 5 minus 1, the number of jumps times the difference, which is 6. And this gives me my last term was 10. And we knew it was 34 by writing it over here anyway. Last term is 34. And then we could do the sum of those terms in terms of first plus last. Now this first plus last formula is actually a form of very similar to doing the midpoint. Midpoint is the smallest plus the largest divided by 2. But we need to say that we've got how many numbers in the list as well now. That's the only difference between the midpoint formula and what we're doing. So we've got 5 over 2. The first value was 10. The last value was 34. And I'll multiply those. I've got 44, 22 times 5 is 110. Either method works. They are handy to know both methods. And the final thing, we'll just do a quick check. 50 plus 50 is 100 plus 10, that's 110. So we can solve those sorts of problems using these. Another common problem though is if you're given 2, can you just flash your microphones if you're okay with that? It seems to be. What I'm going to suggest you do, 20th term, Now we do need to move on with other bits as well. So we need to move on for another question, a bit similar to the example they've got on the opposite page. So the other example they've got is, if I've got the sixth term, and that is 20. The 11th term is 35. What I can say is that A of 6 is number 20 is, and use the formula, I don't know what A1 is. I don't know what the last term is yet. I do know what the last term is. I'm using the wrong thing. Start with A1, and we're going to add to it. It's the sixth term, so n is my 6. N equals 6. And the difference we don't know yet. 11th term, n equals 11. A of 11 is 35. I've got the first term plus the 11th term minus 1 times the difference. And that gives me two simultaneous equations. The first one is from the first equation. We've got 20 equals A1 plus 5D, and 35 equals A1 plus 10D. If I subtract the two equations, I should get an expression for D only. So there's equation 2 and equation 1. If I do 2 minus 1, I'm going to get 15. The A1s cancel out, is 5D, so I now know D is 3. And the second part I can do is I can put that into one of these formulae and find out what the first term was. So A1 is equal to, put that into equation 1, so A1, so 20 plus is A1 plus 5 times 3, so A1 is 5. So I can now write an expression for the general term, AN, and this is a general term. General term, or the position to term rule, that is the A1 value plus, and it's quite fine to put an n minus 1 in there, times D, and D in this case is 3. You don't necessarily have to have expanded and simplified if they're talking about series, but you can simplify this to a general term. So AN could be simplified by multiplying out the brackets. I get 3n. 5 times plus minus 3 gives me plus 2. And that would actually give me my sequence expression. That's the sequence that's going to be done. And the final part of that, they then want to do, what's the sum? And they want the 100th term, was it? Yeah, they want the 100th term. Lost my pen. There we go. So the sum of 100 terms is the following. I can do the sum to 100. We'll do it with their formula first. So their formula is the n over 2. 2 times the first value, 2 times 5. Plus n minus 1, n is 100, times D, which was 3. So that's 2a, n minus 1, and D. That's what those 3 bits are. And that's an n as well. plug the values into your calculator, and 50 times 10 plus 99 times 99 times 3 plus 10 multiplied by 50 is 1533.50. Or the alternative that I was talking about before, or the 100th term is the first term plus n minus 1 using the formula above, or even that formula. We know the 100th term, 100 over there is 3 times 100 plus 2. It's 302. And that one comes out as 302. And then I can do the sum, which is 100 over 2, because there's 100 terms. The first term plus the last term, A, L, and N. And then that's, again, 50 times 307. This is 15,350. Okay? So you've got some questions there using those sums of series. When you get to question 8, it says find the maximum value of S. Notice the difference is going down. So what you have to find out is at what point does the term number start going negative. So what's the smallest term before you get go below 0 in question 8? All right, guys? Those questions, you can go off, have a go at them.